At the end of this video, you should be able to explain how Hubble's discoveries led to an understanding that the universe is expanding, summarize the Big Bang Theory, and list evidence for the Big Bang Theory. Chapter 30, Section 4, The Big Bang Theory. The study of the origin, structure, and future of the universe is called cosmology. Cosmologists, or people who study cosmology, are concerned with the processes that affect the universe as a whole. Like the parts found within it, the universe is always changing. While some astronomers study how planets, stars, or galaxies form and evolve, a cosmologist studies how the entire universe formed and tries to predict how it will change in the future. Like all scientific theories, theories about the origin and evolution of the universe must constantly be tested against new observations and experiments. Many current theories of the universe began with observations made less than 100 years ago. Hubble's observations. Just as the light from a single star can be used to make a stellar spectrum, scientists can also use the light given off by an entire galaxy to create a spectrum for that galaxy. In the early 1900s, finding the spectrum of a galaxy could take the whole night, or even several nights. Although collecting new spectra was very time-consuming, the astronomer Edwin Hubble used these galactic spectra to uncover new information about our universe. Measuring red shifts. Near the end of the 1920s, Hubble found that the spectra of galaxies, except for the few closest to Earth, were shifted toward the red end of the spectrum. By examining the amount of redshift, he determined the speed at which the galaxies were moving away from Earth. Hubble found that the most distant galaxies showed the greatest redshift and thus were moving away from Earth the fastest. Many distant galaxies are shown in Figure 1 on the screen here. Modern telescopes that have electronic cameras can take hundreds of spectra per hour. To date, these spectra all confirm Hubble's original findings. The expanding universe. Imagine a raisin cake rising in a kitchen oven. If you were able to sit on one raisin, you would see all the other raisins moving away from you, as is shown in Figure 2 on the screen here. Raisins that are farther away from you in the dough, when it begins rising, move away fastest because there is more cake between you and them, and because the whole cake is expanding. The situation is similar with galaxies and the universe. By using Hubble's observations, astronomers were able to determine that the universe is expanding. The Big Bang Theory emerges. Although cosmologists have proposed several different theories to explain the expansion of the universe, the current and most widely accepted is the Big Bang Theory. The Big Bang Theory states that billions of years ago, all the matter and energy in the universe was compressed into an extremely small volume. If you trace the expanding universe back in time, all matter would have been close together at one point in time. About 14 billion years ago, a sudden event called the Big Bang sent all that matter and energy outward in all directions. As the universe expanded, some of the matter gathered into clumps that evolved into galaxies. Today, the universe is still expanding, and the galaxies continue to move apart from one another. This expansion of space explains the red shift that we detect in the spectra of galaxies. Figure 3, on the screen here, shows a timeline of events following the Big Bang. By the mid-20th century, almost all astronomers accepted the Big Bang Theory. An important discovery in the 1960s finally convinced most of the remaining scientists that a sudden event, the Big Bang, had taken place. Cosmic background radiation. In 1965, researchers using radio telescopes detected cosmic background radiation, or low levels of energy evenly distributed throughout the universe. Astronomers think that this background radiation formed shortly after the Big Bang. The universe soon after the Big Bang would have been very hot and would have cooled to a great extent by now. The energy of the background radiation has a temperature of only about 3 degrees Celsius above absolute zero, which is the coldest temperature possible. Because absolute zero is about negative 273 degrees Celsius, the cosmic background radiation's temperature is about 270 degrees Celsius below zero. Like any other theory, the Big Bang theory must continue to be tested against each new discovery about the universe. As new information emerges, the Big Bang theory may be revised, or a new theory may become more widely accepted. Ripples in space. Maps of cosmic background radiation over the whole sky look very smooth. But on a map that shows where temperatures differ from the average background temperature, ripples become apparent, as is shown in Figure 4 on the screen here. These ripples are irregularities in the cosmic background radiation, which were caused by small fluctuations in the distribution of matter in the early universe. The ripples may indicate the first stages in the formation of the universe's first galaxies.
The Big Bang theory states that the universe began with a tremendous explosion. It is believed that about 15 billion years ago, all of the contents of the universe were collected into one very dense, high-temperature, high-pressure point. Then, with a tremendous explosion known as the Big Bang, the universe expanded rapidly from this point. As the universe expanded, some of the energy turned into matter, and this matter started to come together. The matter eventually formed galaxies. The Big Bang released all of the energy and matter that exists in our universe today. This stationary light source emits light in a series of wave fronts that move outward in concentric spheres. Each observer sees the same normal wavelength of light. Now let's see what happens when the light source moves. The light source emits light in wave fronts that center on the location of the source at each point along its path of motion. The light source continues to move, emitting additional waves as it travels. When a light source moves, observers see different wavelengths depending on whether the source is moving toward or away from them. An observer in front of the source sees waves with shorter than normal wavelengths. For the observer behind the source, the wavelengths appear longer, and the observer sees a longer than normal wavelength. The light waves are said to be redshifted. In 1929, Edwin Hubble measured the redshift of hundreds of galaxies and announced his conclusion that the universe is expanding.
A universe of surprises. Recent data, based on the ripples in the cosmic background radiation and studies of the distances to supernovas found in ancient galaxies, have forced astronomers to rethink some of the theories about what makes up the universe. Astronomers now think that the universe is made up of more mass and energy than we can currently detect. Surprisingly, analyzing the ripples in the cosmic background radiation tells us that the kinds of matter that humans, the planets, the stars, and the matter between stars are made of makes up only 4% of the universe, as is shown in Figure 5 on the screen here. Another 23% of the universe is made up of a type of matter that does not give off light, but has gravity that we can detect. Because this type of matter does not give off light, it is called dark matter. Dark energy. Another surprise is that most of the universe is composed of something that we know almost nothing about. The unknown material is called dark energy, and scientists think that it acts as a force that opposes gravity. Recent evidence suggests that distant galaxies are further from Earth than the current theory would indicate. So many scientists conclude that some form of undetectable dark energy is pushing galaxies apart. Because of dark energy, the universe is not only expanding, but the rate of expansion also seems to be accelerating. At this point, you should be able to explain how Hubble's discoveries led to the understanding that the universe is expanding, summarize the Big Bang theory, and list evidence for the Big Bang theory.